Hello guys. Today we have a Lenovo an all-in-one, and it's missing the backlight. I'm not sure if you are aware of the backlight, meaning it's turning on, but there is nothing on the screen. Let's connect the charger. You can see the fan is spinning. It's turning on, meaning it's turning on. Let's see. Do we have anything on the screen? No ways. There is no display, as you can see. In fact, we do have a display, but it's missing what? The backlights. If you can use a light or a torch, you can definitely see, but it's just missing what? The backlight. Okay, guys, this thing it can be caused by the strain on the laptops or at the LVDS cable, but here on the all-in-ones, I'll show you right now under the microscope. Normally, there is a fuse responsible for a backlight. Let's have a look under the microscope and see if our fuse is fine. Okay, to find that fuse, you need to navigate near the strain cable or the backlight cable. In this case, I was strolling around the backlight cable going to a back inverter. I will explain that later on. Here we have a fuse, the tiny fuse there. There's no voltages on the other side of that fuse, but we have the voltages on the inputs, but on the outputs there's nothing. There's like 0 volts. Anyway, there are so many things that can cause this fuse to blow up. Number one, it can be a short. In case there was a short or there is a short on the board, that fuse can blow up and then cut the power, so that there won't be any power going through that fuse. So the fuse will distract itself, so that there won't be any power passing through that fuse. Anyway, guys, so what I will do in this case, I normally change the fuse. So let's go ahead, let's change that fuse. Okay, let's go ahead and let's change what? Let's change that fuse, guys. And when I check for short, there is no short on this fuse. When compared to ground, there is no short on this fuse. Anyway, let me push the microscope. Let's have a look at that fuse. I want to show you, because I know I was showing you under the microscope, but let me show you direct, straight. Let's have a look. So what you do, you put your multimeter into continuity mode, and then you touch both ends of the fuse. As you can see, there was no continuity, and you put one probe to ground to check for what? For a short. When I checked there was no short at all. Then it means we are safe. We can go ahead and replace what? Replace the fuse. Anyway, let me show you that cable. The LVDS cable goes straight into this thing, and that thing there, it's an inverter. It's a back inverter. So what it does is take the 19 volts or the 12 volts from the main board, and then it converts it into what? Into a higher voltage for the backlight. Let's go ahead, let's have a look under the microscope. I want to show you how to replace the fuse, but I'm worried because I don't have the foil. I'm gonna try to use a heat resistant tape, but in this case I normally prefer to use what? To use a foil, because a foil normally it can take any shape. You can shape it to any shape, and it can cover up all the plastic components safe and neat. I prefer using the foil, but unfortunately I don't have the foil. So let's proceed with the heat resistant tape. Okay, now let me check for a fuse. So we need to find a replacement fuse. Normally I use these boards, these motherboards, these tiny boards. I get them from the screens, from the laptop screens. Whenever they're broken, I normally remove that back circuit. This is a back circuit, the circuit board. So they have the fuse there. I normally like to keep them. That's where I get what I get my fuse. Now I'm worried, as you can see. That's tape, heat resistant tape. It didn't protect what? It didn't protect the connector uh, properly. It spans. You can see those black spots. But I'm worried. Anyway, don't worry, guys. In case I burn it out, I can replace it. I can remove it completely and put another plastic connector there. And the good thing about doing what? About doing motherboards, you can always burn things and then replace them again without any problems. Anyway, let's see the moment of truth. I'm gonna connect the charger and then we'll see from there whether our problem has been solved. And the machine is starting up. You can see the fan is spinning. Oh, let's see. Oh, guys, it doesn't look good. we don't have we don't have anything on the screen. This is bad. Hi, this is bad. This is bad. Anyway, let's check the fuse again. No ways, the fuse is bent again. The fuse is bent. Okay, you know what? It means we have a short, even though it might not appear on the fuse, but I'm gonna tell you this, but it means on the other side of the back converter, we have what? We have a short. It's possible, or maybe the screen itself is the one burning out those fuse. Where there's plenty possibilities. Anyway, let's have a look at the back converter. Maybe we have a problem with a back converter, guys. Let's have a look. You will never know, I'm telling you. There are plenty of possibilities. You see, at first I thought the issue was the fuse, but it's turned out that it's not the fuse. There's something that keeps on burning those fuels. So it means we have to find the problem. We have to trace the actual problem and see why those fuels are burning out left and right. Okay, anyway, what you need a multimeter, and then you turn your multimeter into continuity mode. You put one probe to ground, and then no. Here, I wasn't doing that. I was checking the continuity to see whether the cable is working, and as you can see, 0.2 ohms. It means there is a connection from that point to another point. They're all connected. They're all connected, and I check the fuse there on the back converter, and the components are fine, but we have a short of 0.9 ohms on one of the capacitors. We have what? We have a short. Anyway, let me show you. Yes, this is the back converter. You can see how tiny it is. That tiny circuit board there, what it does, again, it takes the 19 volts or the 15 volts or the 12 volts from the main board, and then it converts it into a higher voltage. For instance, like 50 volts, 60 volts, or 70 volts, even 100 volts. Depending on the backlight or depending on the required output for the backlight. Anyway, let me show you. Let's have a look. There's nothing much on this board, as you can see as well. What can cause a short here? Obvious, it can be this chip, but again, and it can be this transistor here, and and then this transistor here. What it does, it's very simple. It takes the 12 volts and then convert it into a higher voltage. You have to put your multimeter into continuity mode and then touch those legs to check for continuity. There shouldn't be any continuity, and there was no continuity when I was checking this. But obviously, make a pin, it will have the continuity because it's one thing, it's one pin. That's obvious. Meaning, this is fine, guys. And what you do, you reverse your probes, put your multimeter into diode mode, and you check again. See if there's any reading on both sides. You know, since the transistor they have the diode inside, meaning they shouldn't have any readings from both sides. Same thing you do here with this diode. Put it into diode mode, and then you check whether there's a reading on both sides or not, and check whether there's a short, whether it's shorted or not. But this guy seems to be fine. There we go. We have a short. Something is shorting here. One of these capacitors is shorting, I believe, because it's not the diode and it's not the transistor, but one of these is shorting out. So let's see which one is causing a short. So what we can do is we can inject the voltage to find the actual one, but since it's just the four of them, you can remove one by one. It's only four. So let's go ahead. I'm gonna remove one by one, and you can check. You can see a shorted capacitor if you remember very well. Normally check it like this on the sides. See whether there's any tracks underneath. I don't trust that one. There is a track there underneath that black thing. There is a tiny track there. I can see it. And again, I might be wrong, but that one, the top one, top two, and the one on the right hand side, I suspect that guy. Anyway, let's start with that one, the top one, the one on the right hand side. Let's take it down and let's see if there's any shorts, okay, on that capacitor. I'm gonna take it down. Let's check it. And what do you know? It's shorted. Anyway, I was right 100%. Ah, can't believe this. All right, now let's check the board. Obvious, there is no short anymore after removing that capacitor. Anyway, I'm so happy, guys. There is no short at all after removing that cap. Let's find a replacement one. I'm done. Let's put back everything. Let's go ahead, guys. I'm happy that I managed to find these shorts. Anyway, I hope you are learning, and I will keep on doing more and more and more videos, guys. Anyway, bye bye and take care. Cheers.